Hello, my name is Dimitri Desmidt, and today I'll be introducing a significant networking enhancement coming to VCF 9.1 VPC Span. In previous VCF releases, VPC subnets were automatically pushed to all clusters within the instance. This meant that applications, whether VMs or Kubernetes workloads, could be deployed anywhere by default. With VCF 9.1, we are introducing more granular control. While VPCs connected to the default transit gateway still maintain that global availability, you can now deploy additional transit gateways with a custom span targeting specific cluster. Any VPC connected to these gateways will inherit that span, restricting its subnets to only those designated hosts in the vCenter clusters. So what does that mean for the vCenter admin? Primarily, it allows for precise control over where applications' networks are surfaced. This enables granular application placement and policy enforcement. You can also have dedicated clusters for specific use cases, such as isolating DMZ applications to a restricted set of hosts. And finally, when using distributed transit gateways, this ensures that your VLAN only need to be plumbed to the relevant clusters, significantly reducing your network fabric requirements. Okay, now that we have covered the architecture, let's see how this actually looks in VCF 9.1. The demo will be in 3 parts. For the first part, you'll see in my lab, we have 3 vCenter clusters, and by default, the default transit gateway spans across all 3. This is a great fit for customers who do not want to lock down a specific vCenter cluster for just one type of workload. For example, when you deploy applications like finance and marketing on their own dedicated VPCs, those subnets are instantly accessible everywhere. This means you can seamlessly spin those workloads across any of the available clusters. Starting here in the vCenter UI, you can see our 3 vCenter clusters. Currently, we only have the default transit gateway using the default span that blankets all 3 clusters. Because of this global span, our dedicated finance and marketing VPCs are available across the entire environment. And as you can see right here, under the network view for each cluster, every single one has full access to those VPC and those VPC subnets. This gives us the flexibility to easily distribute and run these application workloads anywhere we want across the infrastructure, as done currently. For the second part of the demo, let's talk about the customers who want to dedicate a specific vCenter cluster to a single workload type, for instance, cluster 3 for DMZ applications. To achieve that, cluster 3 is configured with extra secure ESX settings, and it sits behind a dedicated firewall. Because of that security posture, we want to use this cluster exclusively to host our DMZ applications. So first, we live vMotion the finance and marketing workloads completely out of the cluster 3. Second, we spin up a new transit gateway DMZ in a dedicated mode that only spans cluster 3 and hook it up northbound to that DMZ firewall. And finally, we deploy our DMZ applications right into the secure VPC DMZ. The DMZ applications can only be spin up in cluster 3 since that's the only cluster where that VPC DMZ exists. Back in our vCenter UI, the first step is to clear out cluster 3. Let's use live vMotion to move the workloads belonging to our finance and marketing VPCs completely off this cluster. Now that cluster 3 is entirely free of general workloads, we can safely repurpose it as our dedicated DMZ cluster. Let's configure now a new network span that is dedicated strictly to cluster 3. I give it a name, make it exclusive, and select cluster 3. you can notice that cluster 3 is automatically dropped from the default span, meaning it can no longer see nor host the finance and marketing workloads. And so now, with our span ready, let's create the new TGW DMZ using that new DMZ span. We have the choice between a centralized or distributed transit gateway here, and for this setup, we'll select centralized. I map it to the external connection I previously configured, pointing to our DMZ firewall. And we don't strictly have to do this, but since I have InfoBlocks in my lab, I'll choose the InfoBlocks external block so that it will centrally manage all future DMZ subnets. Finally, we quickly provision the VPC DMZ using that new TGW and DMZ span. And we add now a public VPC subnet. As you can see now, only cluster 3 has visibility into this VPC DMZ. This proves our architecture works. Any DMZ application workload must be running on cluster 3 and is routed out to this secure DMZ. Now for the third and last part of the demo. What if a customer has a cluster with a unique performance traits, like cluster 1 here with features fast storage I/O? We definitely want to use this cluster for heavy workloads like databases, but we don't want to completely lock it down. We want other applications to share the space if there is capacity. To build that out, we spin up a new transit gateway aligned with this cluster and deploy our applications like shared database right into it. And because this cluster isn't running in a dedicated mode, it can also receive standard workloads running on the default transit gateway to keep our infrastructure highly efficient. For this final part of the demo, let's create a new network span called Fast I/O and map it to cluster 1. We are not making this an exclusive span. And because it's non-exclusive, cluster 1 remains actively available within the default span as well. Now let's create a new transit gateway for our Fast I/O workloads and select that span. To switch things up from the last scenario, we're going to deploy this one in distributed transit gateway mode. We bind it to the connection 1 that I created earlier, and once again, since I have InfoBlocks in my lab, let's choose its external IP block. Finally, to unlock richer network services like NAT, let's select the VNA cluster that I previously deployed. With that foundation ready, let's quickly provision the VPC shared DB using our new TGW and Fast I/O span. And let's add a public VPC subnet. Take a look at the UI now. Only cluster 1 has visibility into this new VPC shared DB. However, because it's non-exclusive architecture, cluster 1 can still see and host all the other VPCs on default span. This proves our architecture works exactly as intended. Any high-performance database workload must live on cluster 1 to leverage the Fast I/O storage, but cluster 1 can still simultaneously host standard workloads from the default span to maximize our hardware efficiency. So to wrap this up, in summary, VCF 9.1 delivers precise control over exactly where your application networks are surfaced, enabling granular workload placement and targeted policy enforcement. As we've demonstrated, you can easily carve out dedicated clusters for specialized use cases, such as isolating sensitive DMZ applications to a strictly restricted set of hosts, or you can share specialized clusters with different VPCs and type of workloads. Thanks for your time, and see you on another demo.